Okay, on to some more different styles of factoring. Here's one that's really neat, one you've seen a couple times but probably can't remember in Math 10C. This is called the difference of squares. Why? That's square rootable, and that subtraction sign makes it a difference. So how do you do something like this? Well, this just basically means if you look, there's no x term here. So you can actually write this as x squared minus 0x minus 16. And if you did the PSA on this, right? If you did the PSA on this, look what happens. You want a term that multiplies together to give you minus 16 and adds up to give you nothing. Okay? Now think about this. Two terms that come to mind right away are 4 times negative 4, because 4 plus negative 4, right, gives you the 0. So your answer here is negative 4 and 4. Well, wait a second. Can't you just get that directly from this? Right here. Look. This is x squared minus 16. You know that that term is canceled. That tells you right away that they must be the same, just opposite signs, right? And how do you get that? Directly from this term. Look, square root the x. That's x. That's x. Square root the 16. That's 4. That's 4. And you know that one had to be plus, one had to be minus. One had to be plus, one had to be minus. You're done. That's it. And that works for all kinds of factoring like this. Look at this. Look at this. Same kind of idea. This is square rootable. That's square rootable, right? That's a difference. Perfect. Square root of this, 2x. Square root of this, 5y. Make one a plus, one a minus. You're done. You're factored. It's that simple, that straightforward, okay? So moving on to the next one. Look at this one. Use this idea of difference of squares now in terms of a pattern. What do I mean by this? Look how ugly this is right now. It's horrible looking. But think about it. If we made this into a box and said this is box squared, and I made this into a circle and said that this is circle squared. Look how this is so interesting. This is box squared minus circle squared, which is then a difference of squares. So what would you do with this particular one? Well, simple. I would say, okay, what's the square root of box squared? Square root of box squared is just box. Look, right? What's the square root of circle squared? Oh, that's just a circle, right? Make one a plus. Make one a minus, and you're done. But look at this. What's inside the box? What's inside the circle? What's inside the box is 2x minus 1. Look at that. What's inside the circle? X minus 4. So in fact, what you have here is you have 2x minus 1, right? There, okay? You also have add x minus 4. You have again over here 2x minus 1, but now subtract, and look what I'm going to do. You have to have the brackets around that because of course you're subtracting the whole thing. See what I mean? So look what you've got. Combine like terms. That gives you 3x. That gives you minus 5. Here would be 2x. Oh, maybe distribute this to give you minus x plus 4, right? 2x and minus x is just x. Minus 1 and 4 is just 3. I think this is a lot easier than going out and foiling this guy and foiling that guy and then turning around and doing, oh, that would just be a mess. Always, always look for the pattern, okay? All right.